So in today's class, we are going to study another most important concept. So please kindly focus, focus. Anywhere if you have doubt, anything, immediately you can ask me. But try to make complete attention. It's very tough to understand many concepts from chapter 1, chapter 2. We all people will going to revise that all to solve this concept. So now, as we studied that, potential energy means, as in the beginning itself I told you. So it is not possible to define the potential energy of the body. Only we can define what, everybody? It is not possible to define the potential energy of the body. Only we can define what? All of you. Yes, please. Change in potential energy. So that is what final potential energy minus initial potential energy. So that is what, which is equals, what is the formula we have done? Final potential minus initial potential is equals to minus of work done. So work done also by type of forces. What is the type of forces? Work done by what type of forces? Everybody. Conservative forces. If you want to be silent, then if you are not interested, okay, you stop means I'll stop. So by conservative forces, the work done by conservative forces is equals to change in potential energy. So it is not possible to define the potential energy of a system. We can only define change in potential energy of a system. So that is what we studied in the last class. Am I right, everybody? We solved many numericals also related.
Yes, sir.
So now let us comes to here, basically in like 9th class. So potential energy is actually two types. So keep it in mind. One is gravitational. That's what simply I can say. Potential energy also we can call it as gravitational potential energy. And the second one is elastic potential energy. Of course, elastic potential energy we will discuss later. So we are studying about only the gravitational potential energy. Okay. So now you might be all studying in the 9th class Newton's law of gravitation. Do you remember universal law of gravitation or Newton's law of gravitation? Do you all remember gravitation chapter? Of course, we will study in detail about this force exerted by gravitation. That is what potential energy in the gravitation chapter. For class 11th also we have a gravitation chapter. I think chapter number 6. I think next chapter is gravitation. Am I right? All of you? So I think if my guess is next chapter is a gravitation chapter. So you might be remember that Newton's laws of gravitation, or we can say universal law of motion. This is very popular. Universal law of motion. All of you remember? So universal law of motion says that the force existed between the two bodies is directly proportional to product of masses and inversely proportional to square of distance between them. Do you remember, everybody? Please respond, guys. All of you. Yes? If I combine these two, so we'll get F is directly proportional to product of masses and inversely proportional to square of distance between them from the centers. From where? From the center. Understand? So that is very important. Understand, Mr. Monish, Rudos? The same thing here. Gravitational potential energy means the potential energy present between them. That is what the force. Force is equals to amount of work done. So if you remove this proportionality constant, we'll get something G. Do you remember anybody? G means what? Anybody can tell? G means what? Universal gravitational. Yes, please. Constant. Yeah, universal gravitational constant. You might be all remember the value also. So gravitational constant, which is equals to 6.67 into 10 power minus 11 Newton square meter per kilogram square. Do you all remember this? Yes, please. Yes, sir. Yeah. So that is what you have to remember it. So now, this is what universal law of gravitation or Newton's law of gravitation we used to say. So now with the gravitational potential energy, if you notice it here, which is equals to minus of work done. So work done means force into displacement. So what that is only we can say. So what is the formula? Minus of work done by the force. That is what G minus G into M1 M2 divided by what? R. So if I take the two bodies, so the distance between from the centers, which to call as what? Everybody. and this is M1 and this is M2. Now R means not radius. R means what? Everybody? Distance between from the centers. So this is what is gravitational potential energy. This U only called as gravitational potential energy. Again, 9th class, universal law of, there is a universal law of gravitation or Newton's law of gravitation. From this itself we say gravitational potential equals to minus of G into M1 into M2 divided by R. Is it okay, everybody? Clear understanding or not? Now, so now before going to start the next concept, I want to introduce a concept called as 9th class. Mr. Brothers, I think you are the only one and very few are there. I have taught you a concept called as center of mass. Do you remember? Center of mass, all of you. So nothing is there. I don't want to explain much time on this concept. Nothing is there. For example, if you want to balance a pencil, I have given you the pencil. All of you observe. So I have given you the pencil. I'll ask you to balance in your fingertip. So definitely you will find a midpoint of this pencil so that both the sides is having the equal weight, so that the pencil will be balanced. Am I right or wrong, everybody? Yes, please. Respond. Yeah.
Yes, sir.
So that point is not that exactly center. Understand, Rudreswar? Not everybody is center is located. Whatever the body, for example, I'm having there is a random shape body. So weight, the total body, I can balance it by holding it on a particular point. Understanding? So that is the point we is to call the whole mass of the body is located based upon that point. So that is what we is to call as. What point we is to call as? Everybody? We is to call as? Please respond. Center of mass means a point where whole body weight will be balanced. That is what we is to call as center. Understand that? Please respond, everybody. Clear?
Yes, sir.
So remember, suppose this particle having some weight, this particle having some weight, this particle having some weight, this particle having some weight. So this all the weights is equals to what? Total weight of the body. Am I right or wrong? Everybody? Yes, please.
Yes, sir.
That point, the total weight where the body can be balanced, that is the point we is to call as. What is to call? Everybody?
Center of mass.
Center of mass. Understanding? Center of mass, which will represent with a capital W. Understand, Dureswar? Basically, 9th class, we will take more time to explain this concept. For those and all, some people I have taught them. I think by the time Manya, Samya, Laksha is there, Israel and all not there. So center of mass is the concept which actually will study in 9th class foundation. Okay. So that is where, by the time I have. So there is a point where we can balance the whole body. That is the point we used to call as what, everybody? We used to call as what? All of you. Center of mass. Okay. So that is what. Now, with the help of this, now all of you observe, you all should find in which one, understanding. So the potential energy is like we have to calculate it. All of you observe, if the body changes, suppose if the body is at here, it has been changed in position. So from here to here, it has been displaced. Okay. Now here, what is the potential energy? U is equals to what is that, guys? mgh. And the ground, if it is ground means what is the potential energy, everybody? If it is ground, zero. Yes, please. If it is a ground means what?
Zero.
Zero. Okay. So all of you remember that. So if you notice it, if the body is in ground and it has been shifted to a certain height, then at this point, potential energy is what? Everybody? Yes, please. All of you.
mgh.
Now, imagine, Mr. Sir, if I go to more and 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 more height, if I go, do you think that potential energy, this formula is valid? Yes. So it is not valid.
No, sir.
Mind, this formula is not valid for calculating the potential energy if H is extremely greater. Do you understanding, Ra? Everybody? Please respond.
Sir.
That is what also is one of the important. Now, so I will give you certain diagrams. So chain diagrams we studied. So do you all remember chain diagrams? Yes or no? All of you? So it has been lifted. Like imagine that this is the ground. Okay, Ra, everybody? So from the ground, the chain has been located above h meters. Now, can you tell me what is the potential difference? Anybody? Potential difference is equals to. Fastly, you have to tell. So potential difference. First, identify the center of mass. So center of mass is exactly located middle because from the ground it is located. Every point is on the same height. Am I right or wrong, guys? All of you? Yes, please. So like a pencil, imagine. On the ground, every point is located in the same. So that definitely there will be a midpoint. Am I right, guys? Please respond. So let me consider the total length of the chain is L and the mass of the chain is M. Now, can you tell me what is the potential energy equals to? First case. Anybody? First case. What is the potential energy? U is equals to mgh. Then if this is the surface, can you tell me what is the potential energy? If it is a surface means what is the potential energy? Yes,
Zero.
zero. Clear? Understand, guys? Everybody? Yes, that is what. Now, so the same diagram, same chain I'll give like this, B diagram. Now tell me, what is the potential energy? Now, the chain has been kept like this. So all of you remember, here every particle is traveling the same height. Am I right or wrong, guys? If the body is projected, whatever the particle is, suppose this particle has been, first particle shifted here, then every particle will shift or not? They will travel the same distance or different distances, everybody. They always travel same distance if it is kept in a horizontal. Am I right, guys? Respond. Now, if it is been kept vertically, then so let me take the total height is h. What is the total height, everybody? All of you. So this is also okay. So from here the total height is h. So now all of you tell me. So for this one, so what will happen that everybody now center of mass. So definitely center of mass will be somewhere here. Am I right or wrong? Definitely I can identify. So that is what the center of mass. Now you tell me, do you think that here every point is traveling the same height? That is what is my first question. Do you think every
No,
point
sir.
is the same height? So now, if you take this point and this point, so both are different elevation from the ground. So this is very far from the ground, and this is what? Everybody. This is closer to the ground. Am I right or wrong? All of you?
Yes, sir.
So this is closer and this is far. So definitely there will be a middle concept. So what is the middle concept we have to take, everybody? All of you?
Center of mass.
Of mass. So now if you notice here, see here the center of mass is located above h meters, but here the center of mass is located, see, total is h. Means the can I take this one as what I can take? Anybody can tell? Can I take it as a h by 2? Understand, Dureswar? Pradosh? So from here I am taking the center of mass is equal to how much height? All of you. H by 2. Understand, Amma? Other, that's all. Then potential energy is equals to what is the formula? M into G into, of course, G is acting downwards. H is equals to what? It's not H. H is equals to what? H by.
H we do.
That is what I have to remember. Because center of mass is located at that point. Clear, everybody? Yes. So what is the formula will come? G. Everybody should say it. Mg. Yeah, mgh by 2. Understanding, Ra? Rudreswa? Sai Karthi?
Yes, sir.
Any doubt, please ask me. Asida, clear? One and Samya?
Yes, sir.
Yeah, one more is absent, I think. Who is that? Rohita. Rohit is there. Mr. Monish, communicate, don't be silent. Now, third chain. So the same surface. Now, third chain is kept like this. Now you tell me, is it in what is the potential energy? Anybody? Okay, I'll take midpoint. So midpoint means what is the point we used to call? I already told you. What is the midpoint? Everybody. Midpoint is called as? Yes?
Center of mass.
Center of mass.
The center of mass, and it is lying on the surface. If it is lying on the surface, then what is the potential energy?
Zero.
Everybody. So if it is lying on the
Zero.
surface, irrespective of anything, blindly I can say that potential energy is equals to what? Everybody?
Zero.
Zero. So please make it. Do you understand, everyone? So that is what? So that potential energy, how it will be? Everybody. So greater than, yeah. So that's what we can make it. Do you understand, everyone? All of you? Yes, please.
Yes.
Yeah.
Yes, sir.
So because for case 1 mgh is the potential energy, case 2 mgh by 2. So that which is bigger? First one or second one?
First one.
That is one. Understanding, everybody? Girls? Please respond.
Yes.
So that is what I can say. Okay. Now the concept I am going to make it. Now see, have you seen it? If the chain is in horizontal or vertical or again horizontal on surface, we people can easily find the potential energy. Am I right or wrong? Everybody? Please. All of you?
Yes, sir.
No. So there is a That's what I said. Imagine like, okay, let me draw that. I'll try to make it simplify. So imagine like a spherical one. Okay, so what is this one? Everybody? Spherical. Okay, sphere, you take it. Let me fill with this one is with colors. Now, all of you observe, I'll make it into half. How many? All of you? Please respond. Half. Okay, now again I'm drawing. I make it into how many pieces? How many pieces?
4.
Yes, please. How many equal pieces I made? 4 equal. Am I right? Yes, please. So now every part is same. Am I right with this one? Now you take anything. Now you try to arrange the same chain or whatever it is at this point from here to here. All of you observe how I am arranging. See, for your purpose only, I have drawn actually complete spherical. Usually, I no need to draw that. I can draw semicircle or I can draw only 1/4 of the coordinate. Everything is same. Understanding? Please respond, all of you. So this is the chain. Now we have to find. So this is a big deal. So now what is the potential energy of the chain? That is the question. What is the potential energy of the chain? Do you understanding, all of you? Everybody? Yes, please. So now, when this is like inclination, keep in mind, so they do not have no center of. Yes,
Mass.
please. No center of mass. Okay. So if you simply put, sir, can I put here center of mass? Adi kadayadu. Do you understand, everybody? It is not the right. So because it is inclination. So during this time, we have to do something. Particularly, you take this part alone. So here, what is the angle, everybody? Yes, please. Here, what is the angle? All of you.
90
90 degrees. Now, so as we know, Rudreswar, something is constant remain. From the center, something is remains constant.
radius.
Radius. Oh, very good. So here also radius and here also how much? Radius only. Am I right or wrong? Now this is what is our surface. Then at the surface, what is the surface potential energy at the surface? Anybody can tell?
0.
Yes. So potential energy at the surface is equals to 0. Now, so let us solve this one. So can I draw like this? If you notice it, so there is a, okay. So there is a chain, if you notice it. Now you can see the curve. So this is what is actually the graph. Now, so this also R and this also R. Am I right? Please speak.
Yes, sir.
So now, there is no center of mass. I cannot choose anything. If I choose center of mass, CM, center of mass, it is not right. Do you understand, everybody? Because it is not in a straight line or completely horizontal, like horizontal, or it is lying on the ground. It is arranged in the path. How much coordinate it is? Tell me. Total is total part, total into half and 3. Then how much is this part? Everybody. This is 1/4. And this is also will become what? 1/4. And this is also will become what? 1/4. And this is also will become 1/4. So now how much is the total one? Everybody? How much is that? This is just a part of how much, Ra? 1/4 of the
Very good.
1/4 of the circle. Okay. So that's what you have to remember because it has important. Now, all of you observe very carefully. As it is here are 1 minute. So as it is here are, if you notice, please remember this here at the surface, potential energy equals how much? Everybody? At the surface,
Zero.
potential equals to 0. So keep it in mind that. Now, so if it is not, there is no center of mass, no center of mass, understanding? Then how to solve this one? So that is what you remember, all of you. We'll go with a concept called as. So what is that? Even laws of motion, we have done that same thing. So it is not a perfect, if it is a triangle, okay, we can apply the geometrical, like what is that, and we can find it. But it's not that. It is looks like this. So this is the shape. It's not completely triangle. So what will happen, guys? Now, so there is a concept called, okay. So you can all of you notice it. Concept is small parts. We'll just make that small cuts. All of you observe. So now that cuts, all the lines will come to the where? Everybody come from the center only. Just I am taking a small interval of time and as well as small interval of distance. Do you understand, everybody? So if it is total length, all of you remember, if the total length is equal to how much? L, okay? And total mass is M. Now I'm taking extremely small mass. Extremely small mass means we have to use something. Anybody can tell? Differentiation or
D.
integration? Differentiation or integration? Extremely small.
Difference.
Differentiation. Use Mr. Pradosh, are you clear?
Yes, sir.
So dear, so that's all. Now, if you observe very carefully, so like I can make many millions of parts under this graph, under the concept of called as this DM. Okay, Pradosh, am I right or wrong? So I can make many points. So what is that? What is the way we can find it? What is the total potential energy? So there is a way how we can find by calculating the area under the graph. Am I right or wrong? So, but this graph does not have any center of mass. So what we have to do? The one and only way is we have to find by using a what process? Everybody? By using a small to big R. So what is the process? Differentiation or integration? We have to use it what? Integration concept. Understand the rest first? Second chapter we studied correct under the area under the graph. So just make it into partitions. Okay, then try to find the each one so that you will get the total. And what is the total mass of this chain? Everybody? Total mass of the chain, how much? Total mass of the chain. Please respond. Total mass of the chain, Triyada. Inara. So total mass of the chain, I will take it as a what? Everybody.
M small.
Yeah. So then only it will become what? If the total mass of the chain is M means the small part of the mass will become what? Everybody. DM. Understand this one? Clear everything?
Yes, sir.
Remember from the center, whatever the thing is going. So something is remains constant. At any direction you can go. So what is remains constant? Radius. Am I right or wrong? So till here, just if you are understand this one, anything doubt, ask me. Else this part alone I will draw and I will explain you. So all of you observe very carefully, as it is half of the graph only we are drawing. So please make it everyone. So now this is the graph is basically is coming. Am I right, everybody? Speak loudly. Yes, please.
Yes, sir.
The graph coming. Now they are asking what is the total potential energy. What is our work, everybody? Now in today's class we are going to make it only what is the total potential energy. So there is no center of mass. Yes or no, guys? Yes, please. No
Yes,
center
sir.
of mass it will be. So what we have to do it? Just take a very extremely small distance. So that small distance only we used to call as what? Everybody. Yes, please. The small distance we
DM.
used to call as what? DM. Okay, wow. Now let me take this is one line and this is another line. Now, with the surface, let me take this first one is making a theta angle. So then middle how much angle? Tell me chapter 1 you will get it. Remember everybody, fundamental physical quantities. Speak loudly. Yes or no? So this is the
Yes,
length I
sir.
have taken, brothers.
Yes, sir.
The shortest path I have taken. This is a curved. So like first chapter you might be studied that there is a curve. So the how to find that length, the length of this arc.
L is equal to theta.
Yes. Remember those first chapter we studied?
Yes, sir.
This is similar to like that. Everybody to remember or not? Fundamental physical
Yes,
quantity.
sir.
That is what it is. Okay. So very simple. So now if this is the theta means this will become what everybody? D theta. Am I right or wrong? Small, very short angle, very small angle. Am I right or not wrong, guys? Yes, please.
Yes, sir.
If it is d theta and this is r means, then can you tell me what is the length of this one? Length you can find it. You all people knows. L is equals to what? R d theta. Am I right, Pradosh? Yes, please. So that is what you have to remember. So
Yes.
all of you remember total circle. What is the total circle? Circumference of a circle is how much? 2 pi r.
2 pi r.
Half of the circle is how much? Half of the circle.
Pi r.
And in that 1/4 of the circle, how much it will come? 1/4 of the circle. Pi r.
Pi r by 2.
Okay, please learn that. Any doubt? Any doubt in this? You can ask. Clear, everybody? Now. So now, what is the total length? Anybody can tell me? This is what we can say. The total length of the chain. The total length of the chain is only we can say that one. So what is that, everybody? Which is equals to how much? Yes, please. So now all of you observe very carefully. From this point, I will draw x-axis and as well as you can draw it. Then here is the theta is there. Then here what will come? R. Speak loudly. R.
Cos theta.
Cos theta will come. Okay, brothers. Understand, Dreswa? Anything doubt you can ask me. Then if it is r cos theta, then opposite one it will come as a what? R sin theta, and r sin theta will shift it into parallel. Parallel shift. Then here what will happen? Speak loudly. R sin theta.
R
Understand,
sin
Mama?
theta.
So this is the triangle. So then here is the theta means here if it will come R cos theta and this is radius, then here what will happen? Theta opposite. Actually, it is a
R sin theta.
it is a parallel shift. Understand, Rudreswar, Pradosh?
Yes,
It is a
sir.
parallel shift. So parallel shift it will become R sin theta. In this, anybody having any doubt? Please kindly let me know. Do you all understand, everybody? Yes? All of you? Yeah. Now, if you notice it, the total length, what is the total length of the arc, everybody? The chain? Pi r by 2.
By 2.
Pi r by 2, which is equals to having a mass, how much? Having a mass? M. Understanding? All of you? Now, what is the length of this small part? What is the length of the small part? Everybody. R
RDT.
R
D
d.
theta.
Then can you tell me what is the mass of this small part? Don't say dm. Dm is just that's the part we have considered. Then what is the mass? Anybody can tell? Yes, please. So mass is equals to this. What I
Sir,
said.
D pi R.
Yeah,
by
listen. Yes. So unitary method. By using a unitary method, actually remember we have to study this with this concept. Okay, from this. So all of you observe, if this is the d theta and this is the r, then here it will become what? R. Everybody, r d
D
theta and mass that's very small. Then this will become what? Dm. Am I right or wrong, guys? We studied or not? Because there is a
Yes, sir.
formula we studied first chapter. Arc is equals to what is the formula? R into theta.
Radius into theta.
Yes. Radius into theta. Any doubt, guys? Now, so if you observe very carefully, theta is not remains constant. Am I right or wrong? Who actually varies here? Who is varying here? Theta only varying. Am I right or wrong? Please respond.
Yes, sir.
So theta is varies. Theta is remains constant or varies? Theta is varies. Understand? Theta is variable. Understand, Laksha? So theta is not remains constant because if I take the same distance here, the theta varies or not, Pradosh? For example, if I assume here, theta varies or not? If suppose if I assume here, theta varies or not? Laksha, understand? Aswita? Wherever if I assume, the theta is keep on changing or not? So theta is remains constant or varies? Constant or varies? Everybody? Varies.
Varies.
Then from this part, can you tell me what is that? The very small. So basically we all knows that U is equals to mgh. So now that is for total system. Now very small part. What is the potential energy? Everybody small, very small. So that du is equals to what? Everybody. Du is equals to m become what? Not m. M become small.
dm.
And g is what?
DM.
Only. And h is equals to what? Check it, everybody. H is equals to what? It's not h. H is equals to what?
R sin theta.
R sin theta. Ellame puriyama. Understood or not? All of you. So that is what it is. Now they are asking what? This is for one. Then if you want to find the total potential energy, we have to apply some mathematics concept. What is that? That is for chota.
Integration.
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 Very good. So integration of du is equals to integration of dmg r sin theta. Am I right or wrong? Everybody, are you all clear?
Yes, sir.
Anybody having any doubt? Please kindly let me know. Do you all understand, guys? Now, so by unitary method, I will teach you the mass. Remember, the length is total length is pi r by 2, and then what is the total mass? Everybody, total mass is how much?
M.
M. So if that very small you have taken, what is the length of the small? Everyone, arc length is equals to what is the length of this arc? Length of the
R
arc
d theta.
to r theta. That is why very small r d theta. So r d theta is equals to then mass of that small one, mass of that small chain. Do you understand, guys? Everybody, please speak. So mass of the total
Yes, sir.
mass how much? Total mass is how much? Total mass is equals to m. Now we want only mass of the small arc. Am I right or wrong, guys? That part alone chain. So which is equals to. So what we'll do, for example, the total length if you have taken is L meters and I want only this mass, then and the total mass is M, capital M. Now I want only this mass. So what I will do, I will cut this part from the total length. Am I right or wrong? All of you?
Yes, sir.
Mass of this, that's what it is. So by unitary method, we'll study that also. So the mass of this particular one will become M divided by pi r by 2. M divided by what? Everybody? M divided by pi r by 2. Pi r by 2 is what actually? Total length. Am I right or wrong? M divided by pi r by 2 into small length. What is that small length? Small length is how much? That
R d theta.
So that is the mass of the total mass of the what? M or DM? Total mass of the what? M or DM? Everybody. Total mass of the DM. Okay. Small. The small mass. The small mass is equals to, keep it in mind, the total mass divided by total length into the length of the arc. That is what is actually the DM. Understand, Rudreshwar? Understand, girls say?
Yes, sir.
So you can substitute it by unitary method. So du is equals to, angle is varies from where to where? Check it. Angle is varying from 0 to how much?
90.
90. So angle is varies from 0 to what? Everybody? 90. So that is because theta is remains varies a constant. Theta is
Vary.
varies a constant. Varies. That is what it is. So 0 to maximum how much? 90. So then dm. What is the dm? Dm means we got it here. What is that? M divided by pi r by 2 into, speak loudly.
R detail.
Yeah. So that is what. So r d theta, r d theta. Next what? Into something is there. What is that? G into
J
r.
R sin theta.
Any doubt? Are you clear? Yes, please.
Yes, sir.
Yeah. So now, all of you observe very carefully. Yeah, I have done small mistake. So this is not 1 minute. So there is a small error. It's not r theta. R d theta is only d theta. Okay. Here. So please learn that method also. When the time permits, I will teach you that. Okay. So this is not r d theta, only d theta. That angle. What is the angle? It is angle is how much? D theta. Okay. Mass divided by total length into the angle d theta, which will give you the mass of the dm. Okay. So that is what it is. So here also what will happen? D theta will get r, that will go. Now here this 2 will go what? This 2 will go. Everybody respond. The 2 will go what? Up. So theta will varies from 0 to 90. So it will become what? 2m divided by pi d theta. Okay, wa? Please respond into g into r sin theta. Am I right, guys? All of you? Now, in this, many things are constant. Can you tell me who is constant? 2 is constant, pi is constant, mass of the body is constant, and radius is also constant. These all are constant. Will you all agree with me? Everybody? Yes, please. Respond, Ra. So, can I take this all out?
Yes, sir.
2mgr. Oh, I forgot.
Sir.
Yes, Rudra.
Pi R, sir.
Yeah, pi and r. Okay, Rudreswar. 2mgr divided by all are constant. Am I right or wrong? Yes?
Yes, sir.
Which is equals to what is remaining? What is remaining? Sin theta d theta. Sin theta d theta. Theta varies from where? 0 to? Yes, please. 90. So can you tell me what is a
Sir.
Yes, Rudreswar. Anything missing?
Sir, above we have written 2m by R pi, sir. We not written R pi.
R pi.
Pi R we have written, sir. Pi R by 2 come upside, R we missing.
Which one? This one, huh?
Yes, sir.
2m by. Oh, sorry. Here we did mistake. So this R and R will get cancelled. That's what. Sorry. So here I have removed that. That R I forgot. Understand this one? This R and R will
Okay,
get
sir.
cancelled. Understood? So
Yes,
m
sir.
divided by pi r divided by total length into the length of the small arc. So that r will get cancelled. You will get 2m divided by pi into d theta. Okay, va?
Okay, sir.
Now clear? Understood?
Yes, sir.
Then that r also won't come. Pradosh, understand, Pradosh? That is what. Then 2m g r pi, all are constant, sin theta. So integration of sin theta. Anybody? Integration of sin theta. Integration of sin theta, sin theta d theta is equals to what? Minus cos theta.
Minus cos, sir.
Okay, which is equals to 0 to 90 varies. Now you can substitute it. So 2mgr divided by pi now you substitute it. Minus cos 90 minus of minus cos 0. Am I right or wrong, everybody? So minus cos 90 value. Cos 90
Yeah.
value. Enara? 0.
Zero.
Divided by pi into. So this will go minus of minus. Minus of cos 0 is 1. So minus 1. So minus of minus will become plus, which will become final answer. A final answer how much? 2mgr divided by pi into 1. Am I right or wrong? So what is the final answer, everybody? Yes, please. 2mgr by 2mgr by pi. Okay, wa? Please respond, everyone. So that is the total potential energy. Okay, ra? Everybody, Mr. Narayan, Mr. Monish, total potential energy. If it is the inclined, if the chain is an inclined surface. So here we have to use the chapter number 1 concept, chapter number 2 concept, everything. So keep it in mind, the total length is equals to the mass, capital M. Then the length will reduce to what? Very small. What is the length of that? That is what arc. Arc length is equal to so much, ra? R into
Or d theta.
okay, that is what will become r d theta. So if it is r d theta by unitary method, keep it in mind, then the mass of this small one will becomes okay. So which is equals to total mass divided by total length. That is what pi r by 2 into length of that particular small one. So RR will get cancelled. So what is that, everybody? What is the mass of that one? 2m, everybody. What is that? 2m d theta divided by pi.
By pi.
Yeah, divided by pi. So that is what you have to remember. So if you remember that, that's all. So it will be very simple. So what is that, everybody? Potential energy, total potential energy equals to 2mgr by pi. One of the most important concept, this one. I hope you are all very clear, everybody. So if you understand this, then tomorrow's class I will teach you spring potential energy. Remember about this gravitational potential energy, we will study more in gravitation. Okay, Rudraswa? No need to worry.